The Durienses, the endemic species of the Duero. The Duero River flows through a variety of unique landscapes, from icy mountain summits to dry plains dotted with evergreen holm oaks, from the stunning glacial lakes from which the river springs to the majestic canyon that channels its waters into the Atlantic, and it is fed by dozens of fast-flowing tributaries and a multitude of small, intermittent rivers that dry up in the summer. The Duero River marks the transition between two completely different worlds. Along its banks, the Euro-Siberian and the Mediterranean regions meet and merge in an extraordinary river basin. However, this diversity of landscapes and climatic conditions that characterizes the Duero is as nothing compared to the biodiversity it hosts in its waters. "75% of the fish species that inhabit the Duero are unique in the world, constituting a singular ecosystem that scientists have only recently begun to discover. These are the Durienses, the endemic species of the Duero River, an evolutionary laboratory that has been isolated from the rest of the continent for millions of years. All the species unique to the Duero Basin belong to the Cyprinidae family, a group with numerous species in other European and African rivers. In fact, all the endemic species of the Duero share the same evolutionary line as European cyprinids, but although some species show obvious morphological similarities, others appear to have embarked on a completely separate evolutionary journey. Located on the border between the North and the Mediterranean, the rivers in the Duero Basin have presented their inhabitants with often extreme evolutionary pressures. Conditions in the north of the basin are generally characteristic of European rivers fed by stable rainfall, whereas the hydrological cycles of many rivers in the south of the basin are more variable, at times reflecting those typical of the north and at others of the Mediterranean. As a result, these rivers may be fast-flowing and cold some years, but reduced to a trickle with warm pools in others. In response to this wide environmental variability, the species have adopted singular ways of life that distinguish them still further from the rest of the European fauna, with adaptations ranging from a unique morphology to migratory and feeding strategies that constitute one of the most impressive wildlife spectacles in the world. After a long hot summer, which even the best adapted species have barely survived, the first rains announced the start of a new year for the Duero River. As the temperatures drop and the first snows settle on the peaks, the cyprinids end their period of high summer activity and retire to downstream reaches, where shelter abounds and the rigors of winter are less severe. Their migration downriver leaves many sections vacant for exclusive occupancy by another of the Duero's fish, the trout. With water temperatures that may hover around 0 degrees centigrade and snow-capped mountain peaks, the trout congregate in gravel-bottomed areas where they can lay and fertilize their eggs. Each of the sexes has a slightly different morphology related to the different behavior that males and females exhibit at this time. The females clear their breeding sites of fine particles and organic debris where microorganisms might proliferate, and in consequence, these areas, known as spawning grounds, become highly visible against the rest of the riverbed. Over the course of several days, each female creates a depression in the riverbed using powerful tail movements. Around her, a variable number of males wait in hopes of getting close enough to encourage her to spawn with their convulsing bodies. There is a strict hierarchy among the males, established by striking threatening postures and engaging in very violent fighting for as long as the female works on her nest. The dominant male will gain access to the female and incite her to spawn by flexing his quivering body against her. Meanwhile, the female continues with her digging, using her abdomen to determine whether the depth of the nest is right. This movement indicates to the males that she is about to spawn, and tensions soar. The males now chase and fight each other tirelessly as the longed-for moment draws slowly closer. Once the female is ready, she places her tail over the nest and the dominant male joins her to fertilize the eggs. But he is not alone. The other males follow, hoping to snatch the opportunity to fertilize a small fraction of her eggs. This marvelous strategy ensures high genetic diversity among the salmonids, enabling them to subsequently evolve different strategies and life cycles. From the same nest will hatch individuals capable of reaching an enormous size, but with more exacting needs than those of their smaller fellow spawn, capable of inhabiting rivers with worse ecological resources, but which are equally necessary to provide the species against any environmental eventuality. Once her eggs have been fertilized, the female covers them again with the finest gravel to keep them safe from future strong currents and predators. The embryos will remain buried for several months, maturing very slowly in the icy winter waters until the still distant arrival of spring coaxes them to hatch. Until well into April, snow will continue to cover the peaks of the mountain ranges that encircle the Duero Basin to the north and south. As the sun climbs ever higher in the sky and night temperatures rise, the snow melts and water tumbles downhill towards the streams and small tributaries, increasing the water level in the downstream reaches of the large rivers. The rivers alternate between periods of low flow, when the cold locks the water in the mountain snowfields, and periods of heavy flooding, which shakes the watercourses and stirs up the riverbeds, an effect which is essentially not only for the dynamics of the river itself, but also in order to create suitable conditions for the life which is about to arrive. As the snow thaws, the flow stabilizes and clear waters run from one river to another. Little by little, temperatures rise until reaching the point where life explodes and takes over in a dazzling fashion. Then, all of a sudden, as if by a miracle, there they are. In the first of a spectacular succession of migrations, the northern straight-mouthed nays arrive. Surging forth from their overwintering sites, they initiate a mass migration up the rivers, swimming various kilometers upstream every day, and only slowing down in stretches with very strong currents. Throughout the migration, thousands of these fish make their way along every small channel and seize each slight opportunity to clear an obstacle on their journey upstream. Crowds of them jostle together at the start of the big rapids, waiting their turn to launch into the white water. The stream of fish is endless, constantly replaced by the hundreds that arrive every hour from further downstream. There is no shortage of obstacles along the migratory routes on the Duero, and as a result, the Duero nays has one of the most powerful leaps in proportion to its size of all the fish species in the Duero. groups, and sometimes even dozens at a time. They pit their acrobatic skills against imposing barriers tens of times their height. They attempt all possible avenues, from the most daring to the frankly impossible. But a sufficient number always find a way to surmount the barrier and continue even further upstream. Every obstacle and every stretch of white water operates as a form of selection. Some individuals will never reproduce, and others will never do so again. The rest continue, surging tens of kilometers upstream, to spawn almost as soon as they reach their breeding sites. As their migratory impulse subsides, the Duero congregate in areas with a strong current in order to spawn. Without any mating rituals or violent hierarchies, they lay their eggs in the shelter of stones exposed to the current in a fragile harmony that will soon be broken by the arrival of a new wave of life that is already heading towards these same areas from further downstream. It is the turn of the Duero Barbel. No sooner have the last of the Nays surmounted the river's worst obstacles than more and more barbels appear in their wake. The Duero Barbel is the largest cyprinid in the Duero, and although it is a more active species in the winter than any of the others, it doesn't start migrating until the water temperature rises above 18 degrees centigrade. In terms of numbers and biomass, the barbel is the dominant species in many watercourses in the Duero Basin, and when they start moving upstream, they take complete possession of the river. At the peak of their migration, thousands of enormous barbels swim upstream to breed, encountering the same obstacles that the Duero Nays overcame before them, exhibiting the same powerful capacity to leap and evidencing the same unswerving commitment to their goal. Theirs is a race against time, because the water levels will soon drop. Thousands may gather together in some places, and many of these will find a way to surmount the most difficult obstacles. But, as always, a fraction of the population will pay the price for this journey upstream to reach the breeding sites in time. If water levels remain sufficiently high, some Duero barbels will swim over 75 kilometers upstream in search of spawning grounds as close as possible to the headwaters, even colonizing intermittent rivers that will dry up just a few weeks later. They are seeking the best spawning grounds to complete their life cycle. They swim upriver in search of sites with a strong current, clean water, gravel beds, and optimal oxygenation and hygiene where they can lay their eggs. Indeed, they are looking for sites with characteristics very similar to those selected by the trout in winter, and for the same reasons. In contrast to the nays, the Duero barbel presents complex hierarchical reproductive behavior in which each sex plays a different role that is mirrored in very obvious morphological differences. At the spawning grounds, the tacticians once again deploy their strategies. The more aggressive males defend small plots of fine gravel where the females will come when they are ready to spawn. Changes in hormone levels cause their color to darken and small keratinous growths to appear over much of their bodies. These are large and more striking around the mouth, but can cover the entire body in the most powerful specimens. Until recently, it was thought that these protuberances were used to encourage females to spawn, but our cameras have revealed a very different purpose. Aggression quickly runs rampant among all the males in the same area, which rarely returns to complete calm. Time and again, they defend their territories by attacking intruders with their protuberances, repeatedly striking any part of the opponent's scaly armor that has been damaged to increase the effectiveness of their attack. All intrusions are immediately rebuffed, establishing a mosaic of breeding sites that lack only one thing: the females. The females are larger than the males, and they circle the males' territories, trying to steer clear of the fighting. However, before releasing their eggs, they must prepare the ground by removing any organic matter and creating a depression with small stones that they move using a mouth specially adapted for exploring the riverbed. Several females can collaborate together to clean and prepare the same area, removing gravel and sand from the riverbed and depositing it at the site where they will later lay their eggs. This sometimes represents a disaster for the Duero nays, which only a few days earlier laid their eggs in the same place. These may now be devoured by the barbels, who thus encounter an additional source of energy for spawning. As the females' work advances, the underwater landscape is transformed. For animals not previously attributed with the capacity to modify their environment, they make unimaginable changes to the riverbed. Once the nests are complete, aggression between the males reaches its peak. The fighting is constant, and even the females are attacked probably mistaken for male intruders. In the face of such high tension, the females roam around the spawning grounds trying to work on their nests before being expelled due to an excess of male zeal. Finally, when the time comes, a female spurns the territories that do not interest her and heads decisively towards her chosen breeding site. Her body language signals to the males that she is ready to spawn, and they streak after her through territories that are not theirs. The female positions her powerful anal fin between the stones, creating a small furrow, while males from all the neighboring territories flock to fertilize her. Of course, it is the resident male who reaches her first and who will fertilize the largest number of eggs, but several other males also manage to release their sperm onto the eggs. However, the fertilized eggs are now in great danger. After fertilization, other females and males who did not participate now approach to devour any eggs not protected between the stones, a behavior that has never before been documented. Neither was it previously known that the resident male plays a fundamental role in defending the eggs from these predatory intruders. He ferociously expels all the males attempting to feast on the eggs. Although he metes out less harsh treatment for the females, probably because some of them will use his territory when it is their turn to spawn in the coming days. The cameras have again revealed another complex behavior that favors genetic diversity in the offspring. Even more so when we consider that each female repeats her passage through the spawning ground several times, and one of the males accompanying the owner of the territory will vary on each of these occasions. As a result, populations are more robust and have a greater capacity to adapt to changes in the environment, an essential attribute in the Duero Basin. The Duero barbel and nays are the largest fish in the Duero, together with the increasingly rare bordalo, or northern Iberian chub. This species, Squalius caroliteti, has very small but widely distributed populations which form multi-specific shoals with other cyprinids. These shoals contain other endemic Iberian species that are frequently overlooked due to their small size and because they inhabit marginal river habitats that are more difficult to study. The bermejuela is a small cyprinid widely distributed throughout the Iberian Peninsula. Its name refers to the striking vermilion color of its fins, especially in the breeding season. During the summer, the bermejuela forms shoals containing dozens of individuals that also include juvenile nays and barbels, groups of Iberian gudgeon, chubs, and even trout fry. In contrast, the bermejuela's closest relative, the sarda, lives exclusively in a few tributaries of the Duero and the Tagus, and its main habitat is threatened by the worsening climatic conditions in the region in which the rivers flow. Another small cyprinid species has passed almost unnoticed despite undertaking one of the most spectacular migrations in the Duero Basin and playing a major role in the rivers it inhabits. The calandino. In their thousands and even tens of thousands in rivers such as the Turmes, the calandino start their migration just a few days after the Duero barbels, as soon as the flow slackens a little and water temperatures rise above 20 degrees Celsius. Despite their small size, they must tackle the same rapids that faced the larger Duero nays and barbels a few weeks earlier. this is not the only difficulty they will encounter. The multitude of Calandino gathered together at the foot of the fastest flowing rapids represents an unmissable bounty to an opportunist such as the Duero Barbel. While the European barbel seems content with a more modest diet, the Duero barbel has developed a unique predatory instinct that is fully revealed at this particular time and place. At the peak of their migration, the Calandino form vast throngs at the start of the more difficult stretches. Thousands upon thousands arrive and immediately seek the shallow waters at the riverbanks, avoiding the deepest parts where the barbels tirelessly patrol. A spot in the best hunting site provides access to an unparalleled food source that must be defended by bloodless but effective fights and shows of strength. The result is a horde of spectacular titans, a wall of mouths that any Calandino thrust aside by the current must try to escape by the safest means possible: by air. As it finally approaches the rapids, the entire shoal moves as one, overwhelming the predatory capacity of the large barbels. Surging forward from the pool, the small fish dodge between the mouths, waiting to swallow them in an instant. It is a sprint for life or death through a current lined by predators, and the water boils with movement as each new wave of Calandino arrive. Many are eaten. But with a final thrust of their tails, many more elude the jaws awaiting them. Sometimes it is only by a stroke of luck that they escape the deadly swirl of hungry mouths almost closing around them. But most are protected by their vast numbers, only to encounter new rapids and new predators specialized in their capture. Each zone has its own specialist. In small groups, the Duero barbels patrol the shallow areas, cornering their prey before attacking. At the end of small rapids, at the edge of the white foam, in any area of transit, the barbels establish their hunting territories. During the height of the Calandino's migration, all sites, no matter how uncomfortable, are occupied by predators. So the attacks of some hurl their prey into the jaws of other, occupying any site that offers the chance to devour an easy meal. In the midst of this frenzy, a much more effective and better equipped predator appears, the trout, with a success rate that is light years from that of the Duero barbels. The trout measures its attacks, waiting for the right moment to pounce on its prey and catch it in a mouth lined with teeth. In contrast, the anatomy of the Duero barbels reveals that they are mere newcomers to the world of predation. They have a subterminal mouth opening on the underside of the head, adapted to feeding on the bottom of the river, and no teeth. Consequently, dozens of attacks will fail before they manage to swallow any of the hundreds of Calandino surrounding them on all sides. Nevertheless, thousands of Calandino surmount all these difficulties to finally occupy their own hunting and breeding sites, where they will feed on a multitude of tiny prey to be found on riverbed stones and swept along by the current. For some, it is their recompense for the bloody slaughter they barely escaped at the mouths of the Duero Barbels during their migration. Very occasionally, rather than occurring in successive waves, the migrations of the endemic species of the Duero take place almost simultaneously. Late snowfall can delay the thaw, leading not only to high water levels, but also to a rapid rise in water temperature due to strong solar radiation in May. This creates ideal conditions for all these species to reach spawning grounds that are even closer to the headwaters. Rivers that might go years without seeing them are now filled with all kinds of cyprinid, engaged in an effort to recolonize that is crucial for their survival as a species. Meanwhile, in the larger rivers, several species must share the best breeding sites, completely redefining the relationship between them, especially between the Duero Barbels and the Calandino. Small groups of Calandinos swim close behind the female barbels in the spawning grounds, aware that nest cleaning will stir up small particles and microinvertebrates for them to devour. As soon as the barbels disturb the riverbed, the Calandino gather from all around in search of something to eat. Now it is the turn of the small Calandino to effectively deplete their predator populations. Oblivious to these small intruders, the Duero Barbels engage in their mating rituals, completely absorbed in the task of fertilizing eggs, but in the tumult that follows spawning, groups of small Calandino immediately invade the nests and gorge upon all the eggs within reach. The predator-prey relationship is completely reversed. The prey becomes the predator of its powerful enemy. Interspecific relations in the Duero, isolated from the rest of the world, are as unique and complex as the species that forged them. With the snow already only a memory and water levels plummeting, river temperatures rise to levels only tolerable for our cyprinids, who take possession of the watercourses from the furthest reaches downstream up to the high mountain streams. Near the source, the river water is highly oxygenated, and these reaches form the main habitat of the trout. They also host numerous shoals of Dueronses, who come here after breeding to spend the summer feeding on the algae growing on the stones. This constant cleaning keeps the accumulation of organic matter under control, something which is essential to maintain favorable conditions for the salmonids, other cyprinid species such as the Iberian gudgeon and the bermejuela, and one of the most singular families of fish in these waters, the almost invisible cubittids. The size and shape of minuscule snakes, 3 different cubittid species inhabit different parts of the Duero. These benthic or bottom-dwelling fish live among the stones of the riverbed in relatively shallow water, where they are practically invisible thanks to their camouflage and minuscule size. Their presence is only betrayed by their darting movements as they search for food, grazing on stones, using a mouth located on the underside of their head, which is surrounded by 3 pairs of barbels or whiskers, distinguishing them from other fish species. When summer is underway in the Duero Basin, the cubittids can be seen in slower moving water seeking a mate. Very little is known about the life of these tiny fish in the wild, and it is extremely difficult to observe their entire reproductive cycle. Oblivious to the arrival of other migratory species to the areas that they occupy all year round, the small carbitids form pairs on up to 2 occasions over the course of the summer. The females are larger than the males and have differently shaped pectoral fins, which seems to indicate that these may serve some unknown reproductive function. The rest of the year, these 3 species of Iberian spined loach live quietly, grazing on underwater meadows, heedless of the passage of other species, and appearing and disappearing between the stones depending on environmental variables that we have only recently begun to understand. The eggs laid by the carbitids and the other species currently sharing the same habitat develop rapidly in the high water temperatures. Most cyprinids hatch just a few days after fertilization, and their instinct and habitat preferences drive them to form multi-specific shoals that include many, and sometimes all, of the species inhabiting the same river. However, the formation of large groups does not protect this new generation from all the problems they will face. By mid-July, the mountains have yielded up their entire store of water, and the driest years can often witness periods of up to 4 weeks with no rain and hardly any cloud cover to mitigate the intense evaporation. As a result, the small rivers are reduced to little puddles, veritable oases of aquatic life surrounded by the heat of summer. The smaller cyprinids and juveniles of the larger species have spent millions of years adapted to these enormous fluctuations in summer conditions in the Duero. But climate change is causing these variations to become still more severe, even for the most extremophilic species in the Duero, the sarda. Taking refuge in the last remaining pools of water in the intermittent rivers in the south of the Duero Basin, the sarda thrive despite being surrounded by kilometers of completely dried up watercourses. They are often joined by other cyprinid species, such as some of the last northern Iberian chub, tirelessly patrolling the last pools in the river in search of microinvertebrates to eat. Juveniles of species such as the Durienses and even some Duero Barbels are also present in these multi-specific shoals. The adults probably colonized these watercourses in the spring, but will later die, trapped by the sudden drop in water levels. However, their sacrifice will not be in vain. They leave behind hundreds of fry that share resources with adult sarda barely a few centimeters in length. In response to environmental demands, the sarda has become a specialist in surviving extreme conditions and is capable of thriving here. However, these rivers are dwindling every year, and with them the sarda and chub populations. The golden sun of August lights up the pools in which cyprinids occupy all available space, exploiting all resources and colonizing and thriving in waters reserved solely for species with an enormous capacity to adapt. The Duero's cyprinids have established a flourishing empire in these pools, an orderly universe in which each life is intertwined with all the other lives in the river. Isolated for more than 6 million years, the Duero has subjected its inhabitants to environmental pressures that have fashioned unique species found nowhere else in the world, with adaptations to a variety of conditions ranging from polar cold to extreme heat, and driving migratory behaviors that enable them to flee from adverse conditions and seek an ecological haven many kilometers away. The result is an amazing group of species that enriches a world threatened and shaped by global warming, a unique fish group in a unique river. The Durienses, the endemic species of the Duero.